Okay, we're going to go over, just make first, primary trig ratios. Okay, I'll write that in. Primary.
Oh, sir, these two pictures. Are you recording this one or this one?
Yeah, he is.
Primary trig ratios. So, those primary trig ratios are these three we're talking about here. Okay? Sine is equal to opposite over the hypotenuse of a triangle. Cos theta, the angle, is equal to the adjacent side over the hypotenuse, and tan theta, opposite over adjacent. Okay? Now, a major rule is this only works for right-angled triangles. Okay? So you have to remember that. Only works for a right-angled triangle, which we have examples of here.
There's a 90-degree angle.
90-degree angles, right angle. So, what I want you guys to realize is when you're going to set this up, it always depends on what angle you're talking about. So, for instance, if we're talking about this angle as x or theta, they call it, okay? If this is x or theta, the opposite becomes this side, obviously because it's opposite of the angle. So we would call this the opposite side of the triangle. The adjacent side, there's technically two adjacent sides. Adjacent means to touch. So there's two sides of this triangle touching it, but one side is always has a specific name. Anyone know? Which side is that?
The right side.
The longest side, or the side opposite of the right angle, is always called the hypotenuse. Okay?
Who comes up with these names?
And then what that means is the only side left that's still touching, okay, is considered the adjacent side. Okay? Now, like I said, this completely changes if we're talking about a different angle in the triangle. If we're talking about this angle, first off, actually, does the hypotenuse change?
Yeah.
No.
Hypotenuse is still the exact same side. Okay? It's still opposite of the right angle triangle. Sorry, of the right angle in the triangle. The opposite side now becomes this side. And the adjacent side is the bottom. Okay? So it's very important when you go to set up these primary trig ratios, and we'll go through a few examples of doing it, it's very important that you know what will be opposite, what will be adjacent. Opposite and adjacent completely change every time depending on what angle of the triangle we're talking about. Two other major rules that you guys need to know are angles of depression or an angle of elevation. Okay? We'll draw them separately and then together. So, angle of depression is an angle that goes from a horizontal line and it heads downwards. Okay? So, our horizontal line is the black line here. This x will be our angle of depression. Now, that same horizontal line, if I was looking for an angle of elevation from there, the angle of elevation would be heading upwards from there. This is called elevation.
What does the dotted line represent?
Okay? Dotted line is just the rest of the triangle or the angle we're creating. So it's very important to know what an angle of depression is and an angle of elevation. So I can actually be at the exact same point. I'll show you right here. We're going to be, say there's a person and they're standing here. Let's draw Jaden. Jaden is standing here.
What? He knows.
Hey, look at his muscles. Let's go.
Give him an afro.
There's Jaden. He's standing here. Now, they go to him. Jaden, you need to figure out the angle of elevation, and then you need to find the angle of depression. Those are two separate angles. So from his point, the angle of elevation will be right where he is from the horizontal line upwards. Okay, so there's our angle of elevation. Say it was to the sun. Okay, he needs to find out his angle of elevation to the sun. He also needs to find out his angle of depression. Sure.
He's staring down some stairs.
To the basement. Okay? So he can be at the exact same point and have two completely different angles depending on what we're talking about. The blue is the depression, and the red one is the elevation. Okay? So make sure you understand the difference between those two. You can be at the same point. They're always drawn off of a horizontal line. Very important that you guys
So your battery.
are able to tell that. Thanks. Okay, so we got a question here. How far does Manuel have to kick the soccer ball to put it on the roof of the school, and at what angle? So over here at Neil McNeil, he's going to kick a soccer ball. He is, let's say, 30 meters from the school. So he's quite far away. And the school itself is another 20 meters high, we'll say. Okay? From top to bottom, we're looking at 20 meters, and he's 30 meters from the school. Now, we're going to talk about this.
These questions always mess me up.
He's going to have to kick the ball. We're going to look at a minimum distance. And what I mean by minimum distance is what is the least distance he has to kick the ball to exactly get it on the roof. Okay? Because he could kick it in a straight line or in an arc at an even farther distance. Okay? This line, this blue line, would clearly be farther than this dotted line. We're going to talk about a minimum distance. Now, we're not really going to go into that, but I want to make, in order for this to make sense, we have to say that it's a minimum distance, because you can kick it at many different distances. You can kick it way past that also, right? So, in a straight line, that means he really powers this ball through. It doesn't start to arc or drop at all. How far will he have to kick the ball? So what we need to do, and we also need to figure out some of the angles here. Okay? Now,
90.
we know at the school, it's a 90-degree angle with the floor. We assume the school is built properly. It's vertical.
Yeah.
Okay? Now, in order to figure this out, there's actually a couple ways I can go about this. I can decide to figure out this distance first, which we can call x, or I can figure out the angle of, and which angle will be? The pressure or elevation? Angle of elevation he'll need to kick the ball at. We're going to call it theta. That's the kind of symbol we have over here, and that usually represents angles. Okay? So, we're going to go about this two different ways, and then I'm going to show you a shortcut that you guys actually learned many years ago in order to solve this. So, first thing I'm actually going to solve is we're going to get into the angle. We're going to talk about solving the angle of elevation he needs to kick the ball at. So, since we're talking about this specific angle here, I have three sides of a triangle. We've drawn it, so I'm going to name this triangle. The x is what side of the triangle?
Hypotenuse.
It's the hypotenuse. The wall of the school is what side?
The opposite.
That's the opposite. The reason it's the opposite is because it's the opposite of the angle we're working with, which leaves us with the ground being the adjacent side.
I thought you were talking about the x. What's the
Okay.
case to the x?
So, now, I've named this triangle, that's great, but in order to solve these ratios, I need to actually figure out what sides I have numbers for. For instance, I can bring in all three, so we'll bring in all three of the formulas here. We have our sine, cosine, and tangent. I'll line them up a little here. And what we're going to do is we're actually going to try to solve using all three of them, only to figure out that really only one of them is going to work when we go through this.
Yeah.
So, sine theta, and we are solving for theta, so we know that's fine. Sine theta is equal to the opposite side is 20, over the hypotenuse. Okay? Now, I want you guys to notice this. Theta is a variable, technically opposite, and hypotenuse is a variable. Okay? I have two variables and only one equation. In grade 10, you guys learned in order to solve two variables, you need two equations. We only have one, so this isn't going to work for us. Okay? We try cos. Cos theta is equal to adjacent, which is 30, hypotenuse is x, same thing. I only have one formula and two variables. This isn't going to work. Tangent theta is equal to opposite, which is 20, adjacent is 30. This one I can solve. Okay? I can solve for this. And we're going to bring this into the forefront here. We'll zoom in.
The forefront.
So, we're working with tangent theta is equal to 20 over 30. Now, we're actually only solving for the variable theta. Many of you guys will go about just equating 2 over 3. Okay? So, many of you guys will end up doing this. Tan theta is equal to 2 divided by 3 is 0.6, I believe, repeated. Yeah, 0.6 repeated. We'll just leave it as a fraction, okay? It's 2 over 3. Many of you guys would stop right there, but that doesn't really give me an angle at all. That doesn't help me. Think of this, okay, almost like they're two separate things. And I need to bring tangent over. Okay, tangent is technically an equation. I need to bring this equation over. But when I bring tangent over to the other side,
Negative?
yes. Well, it doesn't become a negative. It becomes to the power of -1.
What?
And 2 over 3. I'm going to explain that in a minute, why it does that. But just know that when it comes over, it becomes tangent to the -1. And if you guys look on your calculators, you're definitely going to need one, okay? If I hit shift, or second function, right now it's just in tangent. Once I hit shift, it becomes tangent -1. Many of your calculators will have that right above. You need to know how to use that, okay? So, in this question, mine's a little different. I have to go 2 divided by 3, and then I hit tangent to the power of -1, and it'll give me, and also look, I'm in degrees. Very important that your calculator's in degrees. We're not working in radians, so make sure it says DEG or D to represent degrees.
Would that be it? DEG right there?
Yeah. And there we go. So 33.69, we'll round it to 33.7. So theta is equal to 33.7 degrees. So in order to get the least distance to the roof, in order for him to kick the ball, the angle of elevation needs to be 33.7 degrees. Okay? Then, at that angle of elevation, how far does he have to kick the ball? Well, we can set this up again. Now, I want you guys to notice, I actually have 1, 2, 3 pieces of information. So we're going to go back to these primary trig ratios and plug in a little more information here. Okay, so we'll jump down to the bottom. Let's try putting them all together. Sine theta 33.7 is equal to 20 over x. Cos theta, theta is 33.7 is equal to 30 over x. And then
Like after sine, theta?
theta, yeah, that's what that symbol stands for. Theta is that thing. It's the angle, okay?
It's an eye.
And then technically tangent 33.7 is equal to 20 over 30. Now, we got to make sense of this also. Tangent is solved. I got all of the variables numbers. Is there a hypotenuse involved in that at all? No. So I can't actually use tangent to solve for the hypotenuse. So even though I have all the information, this is no good for what I need. I need to solve for x, the hypotenuse of the triangle. That's why we've used the other two, cos and sine. I can use either of these, and they'll both give me the correct answer. Okay? So, let's split it.
Wait, haven't you already found the...
We haven't figured out how far he has to kick the ball.
Well, you found the angle.
Definitely found out the angle. Okay? So, let's put these two in. Sine 33.7 equals 20 over x. Cos 33.7 equals 30 over x. Okay, I need to isolate for x in both of these examples. What do I need to do?
You gotta divide by,
Don't you bring 20 over?
cross multiply.
No, but if you bring 20 over...
You can cross multiply to start making sense of this. I want you guys to look at this, okay? We've gone right into one of the difficult questions. This is 20 divided by x.
Yeah.
Okay.
So times the other side by 20.
So, in order to move this x, I need x to be by itself. Now, many guys will look at this 20, and they'll think, oh, if I divide by 20, that'll work, right? But what will actually end up happening is you'll have 1 over x on this side, which is not what we're trying to solve.
We go 21 divided by x.
Okay? So, what I'm going to actually do is I'm going to multiply both sides by x or cross multiply. That's also known as this. We can set up two fractions and is equal to. So, I'm going to multiply this side by x and the other side of the equation by x. Whatever you do to one side, you have to do to the other.
So you divide cos 33.7 by x?
No, we're not dividing, we're multiplying.
Oh, yeah, sorry.
So, we get sine 33.7 times x is equal to 20. Okay? The x's create a 1 or cancel out on this side. And same thing over here, cos 33.7 times x equals 30. Now, the goal is to do what?
On that.
Find x. So how do I isolate for x from here?
On the other side.
Then the cosine and sine.
Yes, we take the cosine or the sine and we divide those on each side.
What's sine? Is that
It's an equation.
So it's not like a number?
No.
So you just divide 20 by 33.7?
Sine 33.7.
Yeah,
Would
because
give you a different answer?
Yeah.
Cosine.
Oh, sorry. Thank you. Not sine. Get me confused. Okay? So we've divided both sides by this. Now on the left, it cancels or creates a 1 like we said. So we're left with x is equal to, okay? X is equal to, now, sine 33.7. I'm going to figure out what that is.
So
33.7.
36. That's
also x equals 20 divided by.
And then 20 divided by that answer. Okay? So we take 20.
That's a lot of work.
It is a lot of work. 0.5548, we'll say.
Is longer than that.
0.5548.
is sine 33.7.
Yep, that's what that is. And then we're going to go divide those two numbers, x. So 20 divided by 0.5548, 36.04, we could say about 36. And on the other side, oh wait, sorry. Close to 33.7, you made a little funny there. Is not the same as sine 33.7. Okay? Cos 0.83.
What the?
Okay, I made a mistake going through it. 0.831. Those are two different numbers. So now when we divide it, 30 divided by 0.831, 36.1, which rounds again to 36. Yes. So remember, what I was proving there is that we can use either of these. You don't have to use both. You can use either to solve it. So we go back up. What did we say? It was in meters? Yeah. So he's got to kick the ball 36 meters approximately to get to the roof of the school.
And that's the minimum, right? That's the minimum.
Very good. I could have just used Pythagorean's theorem to solve that. Because I had this side and this side. But I wanted to show you that there's many different ways to solve things, especially in trig.
Why do the hard way though?
But you asked